Hi, welcome to today's lecture. If you're new on our channel, I want to say a big welcome to you, and for our returning subscribers, thank you so much for keeping us running. If you're not subscribed to our channel, please do subscribe, share these educative videos, like and comment. So for today's learning purpose, we're going to be talking about urine microscopy. Urine is one of those very important samples that can tell us about what is going on in a person's system. So it's very important. So we're going to be talking about microscopy of urine samples today. So when urine comes to the lab, it goes through different processes of registration, tell you produce early morning urine. We're not talking about culture today, but if the urine is meant for culture, you're going to produce early morning midstream urine. But we're talking about just microscopy today. So if the urine is for culture, it should be early morning, the first urine in the morning, and it should be midstream, because we have several types of urine samples, which we'll talk about in our subsequent videos. But for today, we're talking about the microscopy of urine sample. Now, there are several things to look at. Before talking about microscopy. First of all, you want to check about the macroscopy. What are you seeing? Because it will kind of help you or guide you to what you may see in a microscopy. So urine, when talking about the microscopy of urine, first of all, we'll talk about generally the appearance, which entails several parameters like the color of the urine sample. You also check if the urine is turbid or if it's cloudy. You check or if it's clear. So for the color, urine can be amber, can be pale amber, and can also be deep amber. Urine can also be straw colored. That is colorless. Straw colored. And in the event of there being blood in the urine, if there's some quantity of blood in the urine is going to come out bloody. The urine sample can either be amber. Amber, if you know those bottles they used to put reagents. When we say amber, this bottle is amber colored. Just wanted to show you what it means by amber. This bottle now is amber colored. This bottle is amber colored. So some people may say the urine can be said to be yellow, pale yellow, or deep yellow. Any of which suits you. You can either say amber or yellow. So in this regard now, we are working with amber. Let's use the color amber. So now, for this urine sample, you can say this urine is amber. This urine is amber. And then to check for if the urine is, when you say the urine is turbid. Now turbidity means presence of urine. Turbidity is the presence of dirt, visible dirt that you can pick out. But when it's cloudy, you may not really be able to pinpoint any particular dirt. There's a kind of fine dirt that are not really so big. But when urine is not see-through, you can't see through the urine. That means it's not transparent. You say it is cloudy, so you cannot see through. If it's none of these two, then the urine is clear. So we want to check now. This urine, is it clear? Is it cloudy? Is it turbid? Now if you look very well, you find that this urine is turbid. can see some particles inside. You see the urine? The urine is turbid. So for this sample, we'll say color. Color is amber. The appearance, and is also turbid. It's amber and then it's turbid for the appearance. Sorry, appearance. So the next thing to do is to go over to the microscopy. Now, for the microscopy of urine sample, we spin our urine. You use the centrifuge tube to spin the urine at 3000 RPM for 1 minute. And then it is the residue, that's the sediment, that you use for the microscopy. Now, I would like us to know about what we are expecting to see before we do the particles for the microscopy. So what parameters, what are the likely things that we are expecting to see in urine microscopy? First of all, we're expecting to see something you can see as epithelial cell. Can see your epithelial cell. You can also see pore cell. Now, you can also see bacterial cell if present. If present, you can also see yeast cell. You can also see red blood cells. You can see parasites like schistosoma hematobium. You can also see crystals, urinary crystals. You can also see casts. There are a lot of them. You can also see urinary acanthocytes. So, first of all, what are epithelial cells? There are some cells that line some organs, like your squamous cells. There are a lot of them. So these cells now, they exfoliate their own. That's they do what they call spontaneous exfoliation. So they exfoliate on their own spontaneously. Even a normal person should have epithelial cell in his urine sample. It's not a problem. It becomes indicative of urinary infection if it is more than 1 plus. Now you grade epithelial cell in pluses. Now, if you see from 1 to 10, from 1 to 10 per 100 fields, is called 1 plus. That's, you saw between 1 to 10. When you did 100 fields, you saw just between 1 to 10. It's 1 plus. It's 2 pluses if you see 11 to 20 per 100 fields. And then if you see 21 and above per 100 field, is 3 pluses. Or if you see 10 per field, is also 3 pluses. So what I'm trying to say is that it is okay to see 1 plus for epithelial cell in a normal person, knowing that these cells, like I said earlier, exfoliate spontaneously. it exfoliates spontaneously. So if you see one or two epithelial cells in the urine sample, but it is not indicative of urinary tract infection when you see more than 1 plus, like 2 plus. That means something is making it to exfoliate more than usual. Something is making irritating or making the urinary tract inflamed, making it to exfoliate more than usual. So that's where it becomes indicative of urinary tract infection. Now let's talk about pus cell. Pus cells and epithelial cells are shapeless. Epithelial cells are shapeless. They don't really take up a particular shape, but they have nucleus. They have nucleus inside. That's how you know that it's an epithelial cell. Now, for pus cells are degenerated white blood cell. You know, when a white blood cell like your neutrophil go into when there is an infection in the body, neutrophil are triggered to the site of infection to destroy or to mop up or to take out the foreign organism causing the infection in a process known as phagocytosis. Now, in that process of phagocytosis, the neutrophil kills, is self-destruct in the process of trying to destroy the foreign body. So it engulfs the foreign body in a process of phagocytosis and destroys the organism in the foreign body or organism in question. So when white blood cell going through that process of phagocytosis, it results to pus cell. Let's assume your neutrophil has about 3 lobes. But when this neutrophil now undergoes phagocytosis, it looks like this. So this is how pus cell looks like. You just see granules inside the cell. So it no longer looks like this. So this is pus cell. This is pus cell. This is the neutrophil before phagocytosis. Pus cell is graded in ranges. It's graded in ranges. So you grade pus cell from the least thin. This is how we grade pus cell. Least thin to most thin. What do we mean? You grade your pus cell in range. That's what it means. So let's assume you viewed 100 fields and the least you could see in each field was 1. And the most you could see when you went around each field, the most you could see in each field was 2. You say your pus cell is 1 to 2 per high power field. Now we use the high power field to view our pus cell. The high power field is times 40 objective lengths. So say per high power field, you have to tell us that it's per high power field. Times 10 objective lengths is low power field. So you must tell us which power field, because times 10 takes a wider field. So you should see more pus cell with times 10. But when you see between 1 to 2 per high power field, you know that okay, it's times 40 and it takes up a smaller field. So that's why it's important to tell us the power you used. So that's for pus cell. Next up is your bacteria. Like I said earlier, you can see you can see 0 to 1 or 1 to 2, it's okay. But it becomes indicative of urinary tract infection when you see up to 5 pus cells. Up to 5 becomes indicative of urinary tract infection. For instance, you see about 4 to 5 per high power field. This is not indicative of urinary tract infection. So now move on to bacterial cell. There are bacteria infecting urinary tract. You find them present, indicating infection also. Now next, your bacterial cell basically looks like this. Now for your yeast cells, they are fungi. They are indicative of fungal infection. They are indicative of fungal infection. Now, when you see yeast cell, they look like this. You see them budding. If you see the one single, you must look out for the ones that are budding to be sure that what you're seeing is a yeast cell. So this is how yeast cell look like, indicating fungal infection. Now the next is red blood cell. Now you can find red blood cell present in the urine sample for different reasons. One of which is parasitemia, when there are some parasites that have hooks that are able to hook to the lining of the urinary tract when you're avoiding urine, such fashion that at the last part of the urine, they come out with some quantity of blood, making the sample bloody. And so in such sample now, you find red blood cells. So something like Schistosomal hematobium, the urine, you can find red blood cells there. Now when you find red blood cells in urine sample, it can be indicative of parasitic infection. Or if it's a female that is menstruating, you can also find red blood cells there. So these are just some of the conditions where you can find red blood cells present in urine sample. I already told you about Schistosomal hematobium. Is this is Schistosomal species that is found in urine sample. Your red blood cell looks like this under the microscope. It usually is oval with a central pallor. If you don't see the central pallor, you know that it is not red blood cell. Some people mistake pus cell for red blood cell. The difference is the presence of central pallor. And red blood cell does not have granules inside. So you must see a central pallor and that glows. The red blood cell glows under the microscope. Next, the shape of schistosoma, it has a terminal spine. So schistosoma has a terminal spine. You see what I said about lacerating the walls of the tract? Because of this terminal spine is what perforates the wall of the lining of your urinary tract, causing blood to come out with the urine, making the sample bloody. Then crystals. Crystals can be found in the urine sample. There are substances that come together to form what you know as crystal, and sometimes some drugs can also precipitate to form crystals. There are several types of crystals. We have normal and abnormal crystals. Crystals that when you see them normally in the urine, there is no problem. But as some crystals you see, they are indicative of kidney failure or kidney stone. When you see a crystal like your calcium oxalate, it's not an abnormal crystal. Your calcium oxalate this is your calcium oxalate crystal. I don't want to waste too much time. There are lots of crystals. Maybe I'll pick a class and just talk about crystals. There are lots of crystals. Now we have abnormal crystals, like your cholesterol crystal. It looks something like this. Your cholesterol crystal is an abnormal crystal that can indicate kidney stone. And there are some crystals like sulfonamide crystal that indicate the use of drugs that contain sulfonamide. So that's for crystals. Also, casts are debris. They are debris that can also indicate kidney problem. They have several kind of casts. You have your waxy cast, hyaline cast. There are a lot of them. Red blood cell cast. Depending on the cell found inside the cast. So you can have a cast that looks like this. So this is a waxy cast. This is hyaline cast. almost transparent. You need a very good microscope to actually see this. You know, for red blood cell cast, you see red blood cells inside. So that's for cast. The next is urinary acanthocytes. Urinary acanthocytes are indicative of glomerular bleeding. When you hear acanthocyte, your mind goes to red blood cell. So when you see urinary acanthocyte under the microscope when viewing urine sample, it's indicative of glomerular bleeding. We're going to go into this the practicals now for this and show you how to actually carry out urine microscopy. So now, to do the urine microscopy for this sample, you have to mix properly because this urine may have been standing for some minutes. So we're going to mix very well, and when we're done, we transfer it into our centrifuge tube. We transfer the urine into the centrifuge tube. Now, because we don't want to spoil our centrifuge, we must always balance the centrifuge when spinning samples. So I'll put equal measure of water into a second centrifuge tube, equal volume, and then we'll use it to balance the centrifuge at opposite direction to balance the weight. So now we use our bucket centrifuge to spin urine. Like I said earlier, we spin at 3,000 revolutions per minute for 1 minute. We don't want to spin too much so we don't distort the shape of parasites or bacteria or anything if present. So we don't spin for long. So now we're going to regulate this to 1 minute. It's at 1 minute now. It's already at 3,000 RPM. This is for the speed, 3,000 RPM. Then we'll put it to 1 minute. And then, you see, like I said earlier, this is how you balance your centrifuge. You put them in opposite direction to balance the weight so you don't spoil your centrifuge brush. Then you close, then you put it on. So it's now 1 minute. We're done centrifuging. So now we have our sediment and then our supernatant. The next thing to do is to discard the supernatant by quick inversion. So we will discard the supernatant and then we'll use the residue. So in discarding the supernatant, we'll do quick inversion, complete quick inversion. This is it. So that's how you decant. You decant by quick inversion. Then you tap. You tap the sediment. And then you get your clean grease-free slide. You put a drop of the sediment now on your clean grease-free slide. Then we'll cover with our cover slip. And then we'll view using the ×40 objective lens. So now, when you want to focus because this is a wet prep. You know, in my earlier video, I taught you how to use the microscope. Rack the condenser down. You close the iris diaphragm for wet preparation. So that's what we've already done. We've racked our condenser down and we've closed the iris diaphragm. So now, if you look at the screen, you'll see some parameters like we just taught now under the microscope, as you can see. Now, if you look very well, you'll be seeing those round, those things that seem round. I don't know if you can see them. Now, those are the red blood cells. See the ones that have edges that seem to be inconsistent, like crenated, edges that are serrated. Those are light red blood cells. You know, once red blood cell meets water, it gets light. So you know your urine contains water. So some of the red blood cells are actually light, but all of them are actually red blood cells. So if you look very well also, you will see some things moving. Those are bacterial cells. You see some tiny little cells moving. Those are bacterial cells. So now, in this, like I said, I forgot to mention that your red blood cell is also graded in pluses, the same way we grade the epithelial cell. So if you look in this particular field, now you see that there are more than 10. So you know you can say this is 3 plus, or you can say many. Sometimes when you look under the microscope in a particular field, and you see that the particular parameter is just everywhere, like a red blood cell is just everywhere, you can call it many. Like this now, it's just everywhere. It's just everywhere on this field. You call it many. You call it many. Now let's try and change field. So you see, they are just everywhere. You call it many. Red blood cells here is many. So we need further testing to know what's actually wrong. If you look very well, you see some cells that are actually moving. Those ones are bacterial cells. You see them, they are moving. If you look close to 5 o'clock, you see some cells moving. You see some cells moving at about 5 o'clock. You see that those ones are bacterial cells. When you see them moving, bacterial cells, they have flagella to move. So those ones are bacterial cells. See them moving at about 5 o'clock. So there are not much parameters in this particular urine sample. And I want to plead with you, if you watch this video to this point, why not subscribe for more educative content, so that you'll be the first to be notified whenever I drop a new educative video just like this one for you to learn. And I want to believe you have learned a lot about urine microscopy. And if you have any question, you can drop it in the comment section, and I surely be there to answer any question you have. Thank you.